Hello. Let's take a look at another application of t-tests. T-tests are to compare means of two samples. So what we'll do is we have data on a particular quantitative variable, but we have it for two separate samples. Alright, now so what exactly do we have here? Well, we want to analyze the difference between two population means, and of course for that we'll use two samples and see if there is any difference between the two population means, between the sample means. And of course there are some assumptions we need to verify. For example, if we have data on test scores of male and female subjects, and we want to see if there is any difference between test scores between these two based on gender, males versus females. Now to do that we'll use the t-test. If we had to draw histogram of the test scores of boys versus girls, it might look something like this, okay? And so we have hopefully we'll have a normally distributed data, and they're approximately the same variance, so which means it's not too spread out or too narrow as compared to the other distribution. And also maybe there is a difference between the mean of boys test scores and girls test scores. And so the line, the vertical line that you see here, is supposed to represent the mean test score axis, and as you can tell, we maybe have the boys test scores a little less than the girls test scores. And one other thing we need to make sure is that the data have independent observations. What that means is the data of test scores of boys is independent of the test scores of girls, okay, and vice versa. In other words, collecting data about boys test scores did not affect the test scores of the girls. Now, one of the variances that one of the assumptions is that we have a test for equality of variance, and so variance, as you remember, is represented by sigma squared. So sigma squared of the first population is the same as sigma squared of the second population. That is our null hypothesis, and the alternative hypothesis is that the variances are not equal. So we want to verify this. Now there is a test for that. The test involves making a ratio between the two variances. Whichever that's higher goes in the denominator, in the numerator. Whichever variance that's lower goes in the denominator. And we compute an F statistic, and then use this F statistic is supposedly distributed normally, so we're supposed to use a normal distribution, and see if this F value is significantly different from 0. Now SAS has a ways of doing that. Okay, now the test data, for example, for this data, the equality of variance comes F prime, that is equality F prime of the variance folded F. It's 1.51, and that with the probability of finding F greater than 1.51 is 0.74. So which means we cannot reject the null hypothesis that the variances are the same. So which means we can assume that variances are equal, and so we'll go with what's called the equal variance t-test pooled, and we find that the t statistic computed for the difference between the two means equals 0 hypothesis has been found to have a p-value of 0.0003, which is much less than an alpha of 0.05. So we would reject the null hypothesis that mu1 minus mu2 equals 0. And by rejecting null hypothesis, we find support for the alternative hypothesis that mu1 minus mu2 is not equal to 0. In other words, the means of test scores of boys versus girls are different. Now, on the other hand, if we do come up with a different scenario, for example, the equality of variance comes up to be very, very high, and that we find the variances are not equal. So if we have in the equality of variance test, the last line here shows that the probability of finding f greater than that number is very, very small, so which is 0.01, which is less than 0.05. so this null hypothesis that variance of the first sample is the same as variance of the second sample is rejected. So which in other words, variance of first sample is not equal to the variance of second sample. It's supported, so which means the variances are not equal. Now, if variances are not equal, then there is another test that we can use, a t-test called Satterthwaite test, and so SAS does that also, and it comes back with a probability of it comes up with a t statistic of negative 2.45, and which is significant at the 0.05 level. So we have a p-value 0.0320, which is less than 0.05. So this null hypothesis that mu1 minus mu2 equals 0 can be rejected. Alright, so that is the way we would use SAS results for interpreting the difference between means of two samples. Alright, okay, thank you.